In the final and longest subunit of Unit 1, we're going to talk about exponents. Let's start by talking about exponent notation. We covered this briefly when we had talked about order of operations. When we have an exponent, the larger number on the bottom left-hand side is the base. That's the number that we're multiplying out. The upper right smaller number is the exponent, and that's how many times we are multiplying that base. So if we look at the example here, negative 9 to the fifth. Negative 9 is our base. Notice that the negative is included in the base here because it is in parentheses. So that's like saying negative 1 times 9 in parentheses, order of operations, says that that has to happen first. Taking that and multiplying it 5 times. So let's take a look at this example. It's going to lead us into the product property. Let's start with a simpler one first. Let's look at 2 squared times 2 to the third. So 2 squared, according to the order of operations, we have to do the exponents first. 2 squared is 4. 2 to the third is 8. 4 times 8 is 32. Now, the product property for exponents states that we can add the exponents together as long as the base is the same. So this is saying 2 times 2 times 2 times 2 times 2. You can see we started with 2 2's, multiplied it by 3 more 2's. So this is 5 2's multiplied together, and that is 2 to the fifth. 2 to the fifth is also 32. So let's look at this when we are talking about variables like x, just to see that this is true in general. We have x times x times x times x times x. Now the associative property of multiplication says that we can move these parentheses around. So we can group these all together. X times x times x times x times x. That gives us x to the fifth. Now more simply put, if we don't feel like drawing out all these x's every time, we can say that x squared plus x cubed is x to the 2 plus 3, which is x to the fifth. So here we have the product property laid out for you. Notice that the base has to be exactly the same in order for us to be able to add those exponents together. So let's do a few more examples. We have y to the fifth and y to the sixth. According to our example in problem 1, that's going to be the same thing as saying y to the 5 plus 6, which equals y to the 11th. Now in problem 2, our bases are numbers and our exponents have variables in them. But that's not going to change how we look at this. It's still going to work exactly the same. We're going to take our base, and then we're going to add our exponents together. X plus 3x. These are like terms, so we can simplify that to 2 to the 4x. Let's look at our final example. At first glance, it doesn't look like our bases are the same. We have 2a to the 7th times 3a. However, there are no parentheses around the 2a or the 3a, so we can use the commutative property and move stuff around. So we can take our 2 times 3 times a to the 7th times a. 2 times 3 is 6. A to the 7th times a. You can kind of imagine there is an invisible 1 up here. Simply saying a is the same as a to the 1. So that would be a to the 7th plus 1 be a to the 8th. Take a look at problem 3 and see how it goes.